Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a problem number 2, which is based on solution of differential equation using inverse Z transform. Now, as I said, the first three numericals are completely based on transfer function, step response and impulse response, and the next three are completely based on ZIR, ZSR and total response. Now, we know that if you want to calculate a transfer function, step response and impulse response, we will apply Z transform but by assuming all the initial conditions are 0. Now we will move on to question number 2 first. Problem number 2. Here, find impulse response and step response of system which is described by a differential equation y of n plus 1 plus 2y of n equals to x of n and y of 0 equals to 0 value is given. Now, here the initial condition is given and here the value is also 0. So, if we apply a one-sided time shifting property of Z transform formula over here, then also there is no use because here my initial condition is already considered as a or given as a 0. So we'll apply directly Z transform on this equation. Now, my equation is y of n plus 1 plus 2y of n equals to x of n. Now, first term that we are going to calculate is impulse response of system. Now, we can get the impulse response of system if I consider my x of n is del of n. Now, what I can do, I'm going to apply or I'm going to substitute the del of n value in my equation number or the question. So, my y of n plus 1, 2y of n and this x of n is replaced by del of n. Now what I can do, I'm going to apply Z transform on both these sides. So after applying Z transform, what you can say, the Z transform y of n plus 1 is, as I said, the first of all we will write if the function is delayed and if you want to apply Z transform on it, then first of all take the Z transform y of n, that is y of z, and multiply that y of z value by z, and in the power of z I'm going to value the add or I'm going to place that delayed value which is 1 with the sign that is plus 1, and then simply a z transform of 2y of n, that is twice of y of z because 2 is a constant and del of n z transform is represented by del of z, but we know that z transform of del of n is always 1. Now what I'm going to do, I'll take z or y of z common from left hand side. So what you will get, z plus 2 equal to 1. Now I'll shift this z plus 2 on right hand side. Now look at it, we cannot apply directly inverse z transform on 1 upon z plus 2 because so we want a single z in numerator. So what I can do, I'll divide both the sides by z. So here I have got two different factors. So we are going to obtain the step response by applying inverse Z transform on both the sides. But before of that, you can get the inverse Z transform or you can apply inverse Z transform by performing partial fraction first. So if we have two factors, then I can say that we can use two different constants. Let's say A and B are the two constants. So I have written Z in the denominator of A and Z plus 2 in the denominator of B. Now I'll multiply this left hand side denominator on right hand side. So my equation will be, and this is nothing but my equation number 2. Now just simply substitute values of different values of z so that you can get the or you can calculate the values of different values of a and b constants. So first of all I'll substitute z equals to 0 in my equation number 2. So if I substitute z equals to 0, then automatically you can say that 0 into b becomes 0. So you will get the answer only of a. So on left hand side we have 1 and on right hand side we have only 2. And if I shift this 2 on left hand side, you will get the answer of A which is half. Now similarly we will substitute z equals to minus 2. So if I substitute z equals to minus 2, then minus 2 plus 2 becomes 0, then whole A term is replaced by 0. So I can write 1 plus 0 and this z is replaced by minus 2, so we are going to write b into minus 2. So what I can get, I can write 1 is equals to minus 2b. And if I shift this minus 2b on left hand side, my b value becomes, so my b value is minus half. Now I'm going to substitute b and a value in my equation number 1, and then I'll multiply the z on right hand side. Now multiply this z on right hand side. So if I shift or if I place this z over here, so z get cancel. So we have only half as a first term, and then here I'll take this minus half first, or I'll write this minus half first because it's a constant, and then z upon z plus 2. Now we'll apply inverse z transform on both the sides. So we can write inverse z transform y of z is nothing but y of n. Next, an inverse z transform of constant is always del of n minus half into plus, or you can say plus into minus. Answer is minus. Then this half is a constant. Here what we want to write this whole equation like z upon z minus a, because it is the inverse z transform, or you can say this answer is a z transform of a raised to n into u of n. So if I write this 2 as a minus 2, then you can write this equation in this form. So my a value is minus 2 raised to n, and then z upon z minus 1 can be written as u of n. And this is nothing but my answer of first part, that is impulse response. Now we will move on to step response. Now what we want, a step response. So basically we are going to substitute x of n as a u of n, and then we will apply a z transform on both the sides. Or you can say, to get the step response, we will substitute x of n as a u of n. So my y of n plus 1, or this whole equation, can be replaced by, or simply you can say that the right hand side is replaced by u of n, because I have substituted x of n as a u of n, so that you will get the step response. Now we will apply z transform on both the sides. So z transform on y of n plus 1 is nothing but z into y of z. That is, first of all we'll write the z transform y of n, that is y of z, and then I'm going to place this whole plus 1 value in the power of z, which is going to be multiplied with y of z. Now the next one, 2 is a constant, and y of n z transform is y of z, and u of n z transform is z upon z minus 1. Now I'll take y of z common from left hand side, and on left hand side we have z upon z minus 1. Now we want step response, that is inverse z transform of y of z. For that we will shift this z plus 2 on right hand side. Now we can get the step response by applying inverse z transform on this equation, but first of all we will use a partial fraction method. So first of all I'll shift this z on the left hand side. So what we'll get, 1 upon z minus 1 and z plus 2. Now we are going to find out inverse z transform of y of z, but by using partial fraction. And in partial fraction, if we have factors, or if we have two factors, then we will use a two constant, that is a, let's say a and b, and in the denominator of a we will write z minus 1, and in the denominator b we have written z plus 2, and let's say this is nothing but my equation number 3. Now just multiply this left hand side denominator on right hand side. So I'll get this equation, and let's mark this equation is nothing but my equation number 4. Now we'll substitute values, different values of z, so that you will get the answer of all the constants a and b. So first one, I'll substitute z equals to 1 in this whole equation. If I substitute z equals to 1 in equation number 1, what you'll get? The 1 will be there on left hand side, and this z is replaced by 1. So 1 plus 2, answer is 3. So I can write 3a. But if this z is replaced by 1, so 1 minus 1 becomes 0. So whole product term is replaced by 0. So my answer of a is 1 by 3 only. Similarly, I'll substitute z equals to minus 2 in this equation number 2, because if I substitute z equals to minus 2, then this minus 2 plus 2 becomes 0, and a whole a term is replaced by 0. So I can write left hand side value 1 and directly a b value. Z is replaced by minus 2. So we have minus 2 and minus 1. After adding a minus 2 and minus 1, what you will get? Minus 3b. And if I shift this minus 3 on left hand side, what you will get? My b is minus 1 by 3. Now I'll substitute my a value and my b value in my equation number 3, and then I'll multiply this z on right hand side, and after that we will apply inverse z transform on both the sides. So look at here, I've substituted my values of a and b in my equation number 3. Now we'll multiply this z on right hand side. So I'll write this constant part first, 1 by 3 into z upon z minus 1, and minus 1 by 3 into plus, answer is minus 1 by 3, and this z is written first in numerator and then denominator, that is z plus 2. Now I'll apply inverse z transform on both the sides. So applying inverse z transform on both the sides, then inverse z transform y of z is represented by y of n. It can be written as y of n. Now 1 by 3 is a constant, and that is inverse z transform z upon z minus 1, that we know it is nothing but u of n. Next one is a constant term, so minus 1 by 3 I have written first, then z upon z plus 2. As I said in last part also, we can represent this value like z upon z minus of minus 2. So this is nothing but in the form of z minus a, and we know that the time scaling property of z transform, this is nothing but the formula of a raised to n u of n. So my a value is minus 2, so I'm going to write minus 2 raised to n into u of n. Now this is nothing but our answer, so you can stop here also, or else if you want to move further, then you can take u of n common from both the sides. So inside this bracket I can write 1/3 also you can take common. This will be nothing but my step response of system. So similar type of questions asked in exams. So please go through this video so that you can understand, or you will understand how to solve impulse response, a step response, and transfer function of system. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.